Okay, so we just looked at the idea of an inverse of a function, and we showed intuitively how to find the inverse for a given function. I want to look at a more formal method for doing that in this video. And here is the formal method essentially. Step one is to replace f of x with y, and this is just for convenience. It's to be able to not have to deal with this expression f of x, a little cumbersome, as we're going to be basically solving an equation, and so it's just much easier to replace it. F of x is a variable. It's the output to the function f at x, and so we can use the variable y to represent that, right? In fact, we're saying y is equal to f of x. Makes sense. Step number two, we're going to interchange the values of x and y. The sole reason for doing this is simply because we typically like to express our functions as functions of x. We don't have to do this step, but it just helps us when we're thinking about our domain and range. We typically like x to be the input value and y to be the output value. And so that's what we're going to do. That's the reason we do that. Then we're going to solve for y. And once we solve for y, we'll find that y is indeed the inverse function. If you remember, we talked about inverse functions are used in solving equations. And so this should make sense in terms of that. So let's just do this method for this specific example. We did this function intuitively in the last video. I'm now going to do it with this formal process. So step number one says to replace f of x with y. So I'm just going to replace f of x with y. Everything else is the same. Step number two, I'm going to interchange the values of x and y. So my y magically becomes an x, and my x becomes a y. And again, this is just so that our inverse function is a function of x as opposed to a function of y. Okay, step three, we're going to solve for y. And so remember, when we're solving for y, it means I want to get y all by itself on this side and everything else over here. Okay, so how would I solve for y? What would be the first step in doing this? What would be the first step in doing this? Well, I hope you would say that I need to multiply both sides by 11. Basically, I want to get rid of this fraction first so I can get y by itself, get rid of that 11 that I'm dividing by multiplying by 11. So if I multiply both sides by 11, I get on this side, I get 11 times x, of course. If I multiply this by 11, the 1/11 and the 11 cancel, and I'm just left with 4y minus 9. Okay. Now what do I do to get y by itself? Well, I've got minus 9. How do I handle that? Add 9 to both sides. And then how do I get y by itself with a coefficient of 1? I divide both sides by 4. And there I've solved for y. And so step number 4 then says replace y with f inverse. So f inverse of x is what? 11x plus 9 divided by 4. Okay, and if you compare our answer in the previous lecture video, that's what we got when we did it intuitively. So if you think about it, intuitively we're saying let's undo, let's undo this by going sort of in reverse order. And notice as we're solving, that's exactly what we did. What did we do first here? The last thing I did in evaluating the function f was dividing by 11. What's the first thing we did here in solving for y? We multiplied both sides by 11, right? Then to get rid of the minus 9, we did what? We added 9. And then finally to get rid of the multiplying by 4, we divided by 4. So I'm doing the reverse order of these operations and doing the inverse operation in each case. But this is a formal approach, and this will always work, and it's very nice to use. And so let's do that with a few more examples. So number 2, what do we do first? We set y equal to f of x. And that's the cube root there of 2x minus 1. Okay. Number 2, I'm going to interchange the values of x and y. And then step 3, I'm going to solve for y. Alright, so how do we solve for y? What am I going to do first to solve for y here? Well, think about, order of operations in evaluating this function. What do I do first in here? I multiply by 2, then I subtract 1, and the last thing I do is take the cube root. So the first thing I want to do is undo that cube root. How do I undo a cube root? I do both sides of the equation. I cube both sides, right? If I cube x cubed, I get x cubed. If I cube the cube root of 2y minus 1, I just get 2y minus 1. If I cube both sides. Now, what do I do to get y by itself? I first have to get rid of this minus 1. So I add 1 to both sides. And then last, what do I do to get y by itself? Divide by 2. Which, by the way, dividing by 2 is the same as multiplying by how much? Dividing by 2 is the same as multiplying by 1/2. So I could also write it this way. I think that's the way I'm going to write it in this case. And so the fourth step is to say that y is now our inverse function. That's what we're looking for, the inverse function. We just called it y. And again, because we swapped the variables, we get a function of x, which is what we prefer to have. There's the inverse function. And again, you can check these inverse functions. If you remember, in the last video we talked about that. We can take the composition of f with f inverse and make sure that we get what? We get the function x. And that's going to be the case if I do the composition. And I think in the homework a lot of times they have you verify that, so you'll get plenty of practice doing that. Okay. Now, I'm going to use this formal technique on one more example. Okay. And this example, we really need to use this formal approach on. And the reason we need the formal approach here is if I try to intuitively do this, the problem is I've got two things going on simultaneously, because this division bar, the numerator and the denominator really have parentheses around them, so I've got to, first of all, up top, take 2 times x and then add 3, but at the same time I've got to take x and subtract 1 from it. So I've got two things going on at the same time, and the last thing I do is the division. It's just really difficult to do it intuitively, and so we're going to use the formal approach, which is what? Replace f of x with y. Right? And then what? Interchange the values of x and y. And then I'm going to solve for y. All right, how am I going to solve for y here? Now it's getting a little tricky. How do I get y all by itself? Notice I've got 2 y's now. How am I going to do this? Well, remember when you have a fraction in any equation, it's a good idea to get rid of the fractions, and that's what we're going to do. I'm going to multiply by the denominator here, y minus 1, to clear out the fractions. So I'm going to multiply both sides, though. Of course, I've got to do it to both sides. So I've got x times, and notice I'm putting that in parentheses, y minus 1. And when I multiply this by y minus 1, those y minus 1s will cancel, and I'm left with 2y plus 3. All right. So there I've got rid of the cumbersome fraction. Now, what I want you to think about is I want to get the y, of course there's 2 y's, I want to get the y terms all by themselves on one side of the equation and everything without a y on the other. In order to do that, notice I'm going to have to distribute x times y minus 1. I'm going to have to distribute this through. X times y is xy. X times 1 is x. And now I've got terms, right? So this term has a y, this term doesn't. This term has a y, this term doesn't. I'm going to put all my y terms on the left, all my terms without a y on the right. So how do I do that? This term doesn't have a y, so I want to get it over here. What do? Minus x, add x to both sides. This is a 2y I wanted on the other side, subtract 2y. So if I subtract 2y from both sides and add x to both sides, I get this, right? So add x to both sides, I'll have x plus 3, x and negative x is 0, subtract 2y, and then from both sides I get this. Okay? Now, how am I going to get y all by itself? Well, notice I now have these two terms, each have a y factor. So what can I do with that y factor? I can factor it out, right? What am I left with when I factor that y out? X minus 2. It's essentially combining like terms. If you think about it, I'm just combining the coefficients, right? X plus a negative 2 or x minus 2. And now I see how to solve for y. I'm going to divide by this entire expression. And the last step then, once I've solved for y, is to say that that is f inverse y. This f inverse of x is x plus 3 divided by x minus 2. So here's my inverse function. So it's really necessary for us to be able to find the inverse of this function using this formal approach. Okay, so that's what you need to practice on, is finding the formula for the inverse of a function given a certain function, and of course verifying that you have an inverse by looking at the composition of those two functions and making sure that you get the identity function x. So I want to close out then with one last observation, a couple of observations graphically. First of all, if you think about it graphically, if x comma y, right, is a point on the graph of y equals f of x. So notice y is the output, x is the input. Remember, our ordered pairs are input comma output, right? Domain value comma range value, independent variable comma dependent variable, right? If that's the case, since the function will send x to y, our inverse will what? Send y to x. So for the inverse function, the input is y and the output is x. And so basically, if x comma y is a point on the graph of y, then y comma x is a point on the graph of f inverse. And when you replace x comma y with y comma x, you have just performed a reflection about the line y equals x. And I want to show you that here. Look at this function here. This solid line is the function f. The dashed line here, this is the line y equals x. I hope you identify that as the line of slope 1 passing through the origin. Notice that the function f is indeed 1 to 1. Any horizontal line I draw will hit the graph only once. It might look like it might hit it more than once, but really there's only one point there. It just kind of flattens out there, but then every horizontal line hits the graph exactly once. So there's an inverse. So let's see, how would I graph the inverse function? Well, let's start with a point that we see on the graph of the function f right here. That's the point what? X is negative 1, y is 0. Right, x is negative 1, y is 0. So if that's a point on the function, right, if negative 1 comma 0 is a point on the function, then what? 0 comma negative 1 is a point on the inverse. So where's 0 comma negative 1? 0 comma negative 1 is right down here. And notice it's a reflection across this, it's a reflection in this line y equals x. Okay. Another point is right here, right at 1, input 2 is output for the function. So 1 comma 2 becomes what? 2 comma 1. This is also a point. And again, you see it's a reflection about the line y equals x. Let's do one more point here. This looks like a little about negative 0.6 or something here, negative 0.6 maybe. The output is 1, negative 0.61. So if negative 0.61 is a point, negative 0.61, then 1 comma negative 0.6 is a point. And again, I can see that that's a reflection about the line y equals x. Here's another point up here on the function. 3 comma 4 it looks like about on the function. So 3 comma 4 means what? 4 comma 3 on the inverse function. Another point looks like down here, when x is negative 2, y is negative 5. So negative 2 comma negative 5 means what? negative 5 comma negative 2. You see how that's a reflection there. Okay, well, I can continue to plot some more points to flesh this out, but as you do so, what you're going to see is we're going to see the graph looks something like this for the inverse, right? It's a reflection about the line y equals x. Notice this one point right here that's right on the line y equals x, that doesn't move, it's the same, right? Because it's x and y value are the same, right? It's about what, negative 1.3 comma negative 1.3 or whatever it is there, and that stays the same after you swap the order. So that's an important relationship. You can see the symmetry if we sort of draw it that way, how f is the reflection of f inverse and vice versa about the line y equals x. Okay, so that's one thing. That's an interesting observation. I want to close with just some questions about a function and its inverse graphically. If I give you the graph of a function, again, you should be able to sketch its inverse. I'm not going to do that in this case. But notice this function is 1 to 1, right? This is the graph of f. It's 1 to 1. So again, just emphasize this is the function f, right? Any horizontal line hits it once, so it's an inverse. So let's talk about the first question here is just basic, right? Don't even need to know about inverse functions. What's f of negative 3? Well, if I input, right, x is negative 3, what's the output? The output is 3, right? So input negative 3, output 3. Right, because that's the point on that graph right there, negative 3 comma 3. But then what is f inverse of negative 3? Now you might say, well, I don't have the graph of f inverse, right? This is the graph of f. Can we just go to negative 3 and just cheat and just say it's equal to 3? Well, no, it's not, right? The function f, it's f inverse. But here's the thing. If f inverse of 3 equals, I don't know, I'm just going to call it A. I don't know what it is. I'm looking for A. You know, I want to know what goes in this blank, right? If this is true, then what do we know? F of A must equal what? 3. That's the inverse relationship, right? If f of A is equal to 3, then f inverse of 3 goes back to A, right? So what I'm actually looking for when I say what's f inverse, sorry, I should say negative 3 here. Let me change that to negative 3. Doesn't really matter. It's the same in both cases, but negative 3. So what am I saying here? To find f inverse of negative 3, I actually have to find the input to the function f that gives me an output of negative 3. Right, because then the f inverse will send this back to its original input, which is A. Right? So now what am I looking for? I'm looking for an output of negative 3 on the graph of the function f. So where is the function f equal to negative 3? Right here, right? This is the point, what? 0 comma negative 3. So f of 0 equals negative 3. F of 0 equals negative 3. Therefore, f inverse of negative 3 equals what? 0. See how I'm doing that? I've got to do the inverse relationship. All right? Let's see how to do this. F inverse of 0 is equal to what? Well, when is the output to the function f equal to 0? Right about here, right at that point, which is what? Negative 1.5 comma 0. So f of negative 1.5 equals 0. So f inverse of 0 equals what? Negative 1.5. What's f inverse of 5? When is the function's output equal to 5? Where is an output of 5? Way up here, right at this point, which is what? The coordinates negative 4 comma 5. So f of negative 4 equals 5. So f inverse of 5 is equal to negative 4. Now let us close with this. What is f composed with f inverse of negative 4? Remember what this means, right? Circle f inverse is f of f inverse of negative 4. Now, I submit to you that I don't even need to look at the graph to deduce this answer, because when I take the inverse of negative 4, right, and then plug it back into the function f, that's going to bring me right back to what? What I started with, -4. That's the inverse relationship. I know this has to be -4. But to check, let's just see, when is f inverse equal to -4? Well, remember what we're looking for. When is the output to the function f equal to -4? Where does that occur at? Right about here, right? Which is the point, what? 2.5 about, comma -4. And so you'll notice I see that f of 2.5 equals -4, right? And that means f inverse of -4 is equal to what? 2.5. But then I'm immediately taking f of 2.5. What is f of 2.5? We just said -4. It brings me right back where I started from. Okay? And so this is going to be the case. And this is an important relationship. I mean, again, this is the idea behind how we can solve for equations, because basically the function f and f inverse, they cancel each other out. They cancel each other out. Okay, so hopefully this makes sense. There's going to be some practice of this in the homework in my lab on homework set, so please be working on that and let me know if you have questions.